Okay, the next question takes us one little step further, because now the block doesn't just slide along a horizontal surface. From point B, it moves at 4.95, this should be meters per second up here, up a rough inclined plane to point C. So you see it's been moving along like this, and now suddenly it's got an inclined plane. Now I'm going to draw it, it's slightly rough. Okay, and it came along from point B where we last met it, and it gets to this point. In fact, that's not point B, this is point B, where it just gets onto the slope. Okay, so that is point B, and then it goes up the slope to point C. Okay, and there's point C. The speed of the block at point C is 2 meters per second. This thing again. And point C is 0.5 meters above the horizontal. Okay, and it was moving along the horizontal before. Its velocity as it gets onto the slope, at the very instant it gets on the slope, the velocity at B is equal to 4.95 meters per second. That's velocity at C. Okay, what else do we need to know? Well, we just remind ourselves, of course, that the block has a mass of 2 kilograms, and during its motion from B to C, a frictional force acts. Okay, there's a frictional force, in other words, friction will do work against this body. And there is the 2 kilogram body too. So we've got our picture, and we can see exactly what is going on. Okay, now a very popular thing to get exam questions on is the work energy theorem. It is very important. The work energy theorem, we've got to state it. The net or the total work done on an object is equal to the object's kinetic energy. Okay, so the work energy theorem says that all the work done on the body is equal to a change in the kinetic energy. Okay, you put those, if something was stationary and then it was made to move by doing work on it, then that would explain the work energy theorem in symbols. You're asked to do it in words. There it is.